A city block, urban block or simply block is a central element of urban planning and urban design. A city block is the smallest area that is surrounded by streets. City blocks are the space for buildings within the street pattern of a city, and form the basic unit of a city's urban fabric. City blocks may be subdivided into any number of smaller land lots usually in private ownership, though in some cases, it may be other forms of tenure. City blocks are usually built up to varying degrees and thus form the physical containers or streetwalls of public space. Most cities are composed of a greater or lesser variety of sizes and shapes of urban block. For example, many pre-industrial cores of cities in Europe, Asia and the Middle East tend to have irregularly shaped street patterns and urban blocks, while cities based on grids have much more regular arrangements. Grid plan: in most cities of the world that were planned, rather than developing gradually over a long period of time, streets are typically laid out on a grid plan, so that city blocks are square or rectangular. Using the perimeter block development principle, city blocks are developed so that buildings are located along the perimeter of the block, with entrances facing the street, and semi-private courtyards in the rear of the buildings. This arrangement is intended to provide good social interaction among people. Since the spacing of streets in grid plans varies so widely among cities, or even within cities, it is difficult to generalize about the size of a city block. However, as reference points, the standard square blocks of Portland, Houston, and Sacramento are 260 by 260 feet, 330 by 330 feet, and 410 by 410 feet respectively. Oblong blocks range considerably in width and length. The standard block in Manhattan is about 264 by 900 feet. And in some U.S. cities standard blocks are as wide as 660 feet. The blocks in Edmonton, Canada are 330 by 560 feet. The blocks in central Melbourne, Australia, are 330 by 660 feet, formed by splitting the square blocks in an original grid with a narrow street down the middle. Many world cities have grown by accretion over time rather than being planned from the outset. For this reason, a regular pattern of even, square or rectangular city blocks is not so common among European cities, for example. An exception is represented by those cities that were originally founded as Roman military settlements, and that often preserve the original grid layout around two main orthogonal axes. One notable example is Turin, Italy. Following the example of Philadelphia, New York City adopted the Commissioner's Plan of 1811 for a more extensive grid plan. By the middle of the 20th century, the adoption of the uniform, rectilinear block, subsides almost completely and more picturesque layouts prevailed, with random-sized and either curvilinear or non-orthogonal blocks and corresponding street patterns. In much of the United States and Canada, the addressing systems follow a block and lot number system, in which each block of a street is allotted 100 building numbers. Structure variations: the concept of city block can be generalized as a superblock or subblock. Superblock equals. Superblocks were popular during the early and mid-20th century, arising from modernist ideas in architecture and urban planning. Planning in this era was based upon the distance and speed scales for the automobile and discounted the pedestrian and cyclist modes as obsolete transportation vehicles. A superblock is much larger than a traditional city block, with greater setback for buildings, and is typically bounded by widely spaced, high-speed, arterial or circulating routes rather than by local streets. Superblocks are often found in suburbs or planned cities, or are the result of urban renewal of the mid-20th century, where a street hierarchy has replaced the traditional grid. In a residential area of a suburb, the interior of the superblock is typically served by dead-ended or looped streets. The discontinuous streets serve the automobile as longer distances, and the extra fuel required to go between destinations was not a concern, but at the pedestrian scale, the discontinuity of the roads added to the distance that must be traveled. The discontinuity inside the superblock forced car dependency, discouraged errand walking, and forced more traffic onto the fewer continuous streets, increasing demand for through streets, which led ultimately to these streets having more travel lanes added for cars, thereby making it more difficult for any pedestrian to cross such streets. In this way, superblocks cut up the city into isolated units, expanded automobile dominance, and made it impossible for pedestrians and cyclists to get anywhere outside of the superblock. Superblocks can also be found in central city areas, where they are more often associated with institutional, educational, recreational and corporate rather than residential uses. Urban planner Clarence Perry argued for use of superblocks and related ideas in his neighborhood unit plan, which aimed to organize space in a way that is more pedestrian-friendly, and provided open plazas and other space for residents to socialize. Planners, today, now know that the street discontinuity and the multi-lane roads associated with superblocks have caused the decline of pedestrian and bicycle use everywhere this sprawl pattern is present. The traditional urban block diffused automobile traffic onto several narrower roads at slower speeds. This more finely connected network of narrower roads better allowed the pedestrian and cyclist realms to flourish. The superblock, at the scale only suitable for automobiles, and not pedestrians, was the means for ultimate automobile dominance by the end of the 20th century. The same intention to facilitate pedestrian movement and socializing is captured by an influential 1989 conceptual design of a pedestrian pocket. It is, similarly, a superblock composed of 9 normal city blocks clustered around a light rail station and a central open space. Its circulation pattern consists primarily of a dense pedestrian network which is complementary to but independent from the car network. Access by car is provided by means of 3 loops. This superblock differs from Perry's concept in that it makes it impossible for cars to traverse it rather than very difficult. It is car impermeable. In the 1930s, superblocks were often used in urban renewal public housing projects in American cities. In using superblocks, housing projects aim to eliminate back alleys, which were often associated with slum conditions. Superblocks are also used when functional units such as rail yards or shipyards, inherited from the 19th and early 20th centuries, are too big to fit in an average city block. A contemporary function which reflects ancient practices that also requires larger than typical blocks is the sports stadium or arena. Just as the Colosseum in ancient Rome, sports complexes require superblocks. The Providence Park Stadium in Portland, for example, takes up 4 normal city blocks as does the equally large Greensboro Coliseum in North Carolina. Other contemporary institutions, establishments or functions that use superblocks are, city halls like Government Center, Boston and Toronto City Hall. Regional general hospitals or specialized medical centers. Convention and exhibition centers, such as Exhibition Place in Toronto and the Boston Convention and Exhibition Center. And downtown enclosed shopping malls such as Eaton Center in Toronto, echoing the large gallerias of the 19th century. Cultural complexes, such as the Lincoln Center in New York City, often occupy a superblock achieved through the consolidation of regular city blocks. A recent superblock user is the Merchandise Distribution Center, which can range in area from 1 to 10 city blocks. Most notably, however, the largest superblocks in contemporary cities are used by university and college campuses such as Massachusetts Institute of Technology, the University of Illinois at Chicago, the City College of New York, Columbia University and the University of Alberta in Edmonton. The campus impact on the city block structure is quite prominent, particularly in small university towns such as Waterloo, Ontario or Ithaca, New York, where the university superblock counts for a sizable portion of the total city area. Campuses, in general, are fully walkable and sociable environments within the superblock structure. On some university campuses, the extensive and exclusive pedestrian path network at grade is supplemented with below-grade paths. New urbanists would argue that separating circulation modes effectively kills the social interaction that bolsters urban areas. Additional users of the superblock concept are large national or multinational corporations who constructed campuses in the late 1900s and 2000s. Examples of superblock campuses include Google in Mountain View, California, IBM in Summers, New York, and Apple and Hewlett-Packard in San Jose, California. Another well-known commercial superblock is the World Trade Center site in New York City, where several streets of Manhattan's downtown grid were removed and demapped to make room for the center. Social and housing agencies in the US, Canada and the UK used the superblock model for large housing projects such as Regent Park in Toronto and Benny Farm in Montreal, Canada. In New York City, the Stuyvesant Town Private Market residential development superblock takes up about 18 normal city blocks and provides a large green amenity for its residents and neighbors. It uses crescent rather than dead-ended streets inside the superblock and an extensive network of paths that provide excellent connectivity within the block and to the neighboring areas. Where the superblock is used for housing projects like Stuyvesant Town, the advantages sought are an improved separation of vehicular and pedestrian circulation, enhanced tranquility and reduced accident risk within the neighborhood. In 2003, Vauban was constructed with similar goals. Its layout consists mainly of a superblock with a central pedestrian spine and a few narrow-looped and dead-ended streets. The British new town of Milton Keynes is built around a grid of 1 km square superblocks. Unplanned, emergent superblocks virtual, unplanned superblocks have emerged in many cities worldwide as the outcome of stepwise modifications to streets and traffic. Most such superblocks have occurred in European city centres where the street network originates in the medieval or earlier periods. Not only is the street pattern labyrinthine, but also numerous streets that constitute it have dimensions incapable of accommodating two crossing cars or one car and pedestrians, excluding the need for parking or emergency access. Such geometric constraints and the resulting chaotic traffic conditions, along with deteriorating air quality, forced cities to remove motorized traffic from such streets. In certain cases, such as the city of Bremen, Germany, the cumulative effect of excluding motorized traffic from a number of streets made it impossible to cross the old city center by car. The center, however, remains completely traversable on foot or bicycle. A condition that resembles in principle the planned superblock and incorporates its design intentions. Some cities, such as Montpellier, France, expanded the exclusion of traffic from the entire old center. The superblock concept has also been applied retroactively in Barcelona's Ribera and Gracia districts. In these two cases it resulted in an increase of journeys on foot and by bicycle and in higher level of commercial and service activity. The concept is now being considered for application on ideal Fonseca grid. Substructure equals. In a geoprocessing perspective there are two complementary ways of modeling city blocks, with sidewalks, using a direct geometric representation of the usual concept of city blocks. Not only sidewalks, but also inner alleys, common gardens, etc. Some street parts, such as a street greenway, isolated and with no related lot, can be also represented as a block without sidewalks, represented by polygon obtained by the external border of the union of a set of touching land lots. Always a block without sidewalks is within a block with sidewalks. The geometric subtraction of a block without sidewalks from block with sidewalks, contains the sidewalk, the alley, and any other non-lot substructure. Perimeter block equals. A perimeter block is a type of city block which is built up on all sides surrounding a central space that is semi-private. They may contain a mixture of uses, with commercial or retail functions on the ground floor. Perimeter blocks are a key component of many European cities and are an urban form that allows very high urban densities to be achieved without high-rise buildings. Uses, and other uses of blocks. As a unit of distance equals, in North American English and Australian English the term block is used as an informal unit of distance. For example, when giving directions. In British English the term is very rarely used to express a measure of distance due to blocks not being used in town or city planning. Online uses of blocks equals. There have been online innovations and websites such as MSNBC.com owned Every Block, which uses geo-specific feeds from neighborhood blogs, Flickr, Yelp, Craigslist, YouTube, Twitter, Facebook and other aggregated data to give readers a picture of what is going on in their town or neighborhood down to the block. See also, census block, Manhattan distance, mixed-use development, urban design, urban planning, mile road system of Metro Detroit region, grid plan. References. Further reading Jacobs, Jane. The Death and Life of Great American Cities. Random House. The Great American Grid, Block Size Dimensions.